Hi, I wanted to talk to you about some of the common mistakes that I'm seeing in both the work and in your quizzes. And just a reminder, guys, that just like I did in class, I do not go through and check to see if every single thing is correct. I'm kind of looking at and getting a feel for, what you guys are getting, what you're not getting, and some of you are making some serious mistakes. So I want to put this video up for you to see if you're doing it right. Okay, so this is the mass stoichiometry worksheet. I'm going to do two of them in this video, and I'm going to talk about some of the common mistakes. And hopefully you're not making it, but some of you are, and I wanted to make sure that we nip that in the bud. Okay, so everyone knows, although I don't see this on everyone's worksheet, so I'm wondering where, how you're getting your answers. You need to balance your equation first. Okay, so we're going to do number 2 right now. And when we balance this one, we're going to get, there's 2 chlorines here. I need 2 chlorines there. There's 2 iodines here. I need 2 iodines here. And now that gives us 2 sodiums as well. Okay, so after this, then you're supposed to fill in your VCA chart. But some of you are taking the numbers that you see and you're putting it directly into the BCA chart. Remember, this chart has to be moles. So the first thing you need to do is convert your grams to moles. Okay, so we got to take our 0.29 grams of sodium iodide. Okay, don't put it there. Convert it to moles first. So the molar mass of sodium iodide, molar mass, NaI is 149.9 grams, okay, per mole. And some of you are thinking, okay, I need to multiply that by 2 because this says 2 sodium iodides. Okay, don't do that. The only time we're going to use our coefficients is this row right here. Okay, this is where the mole ratio gets used. We don't use it anywhere else. So when we're converting grams to moles, it's just the mass of 1 mole. That's your converter. Okay, so we're going to take our 149.9 grams, 1 mole, and then we get 0.00194 moles. Let me double check that. Always double check these because it's so easy to make a mistake. 0.29 divided by 149.9. Yeah. All right, so that is what goes here. That's what you're starting out with. So you're reacting this 0.00194 with chlorine, and it doesn't tell you how much chlorine, so that's going to be excess. Okay, and then they want to know what mass of sodium chloride. So this is the thing we're trying to find right here. Okay, and we're going to use up all of this. Okay, and then based on our mole ratio, it's a 1-to-1 ratio. So this is going to be the same, 0.00194. That's what we're making. It's what we want, right? They're asking for sodium chloride, but they're asking for mass. So we're not done. We're going to have to take our 0.00194 moles, and this time it's sodium chloride, okay, not sodium iodide, and we're going to convert it into grams. Okay, since we're doing that, it's going to be a different molar mass. It's not this molar mass, it's this molar mass. So when you add up the sodium and the chlorine, you get 58.44 grams. Okay, and this time the mole goes on the bottom so that we can get grams for our answer, our mass answer, 58.44 times 0.00194. And we get 0.113 keep it to 2 sig figs because that's 2 sig figs. Okay. All right, so common mistake, not balancing. Make sure you balance. Another common mistake, not converting grams into moles. Putting grams directly into your BCA chart, that's a no-no. It has to be moles. And then the third mistake, when you are converting grams to moles, that converter, that molar mass, is always the mass of 1 mole, okay? It doesn't matter what these coefficients are. That has nothing to do with changing your grams to moles. And the only time you're concerned about these coefficients is when you're doing the change, okay? All right, let's do another problem. Let's do this one, number 5. Okay, so what mass of hydrogen peroxide must decompose to produce 0.77 grams of water? Okay, so we need to balance. So we have an even and odd. Okay, I have 4 oxygens. I need 4 oxygens here. I have 4 hydrogens here. I have 4 hydrogens there, so that's balanced. Okay, so I'm going to convert my 0.77 grams of water to moles first. I'm not going to put that there. And it's 18.02 grams is 1 mole. Okay, and I'm not using the coefficients when I'm doing this part. It's always 1 mole. Okay, 0.77 divided by 18.02, and we get 0.0427 moles of, this is H2O. Alright, so where do I put this? Here's my H2O, but I'm not going to put it here, okay, because in the before row, we are saying this is before the reaction happens, so these have to be zeros. So then what is this? This is what you're making, right? You're producing this water. So that means this amount is going here, 0.0427. Okay, and I know this, I just like to keep a lot of sig figs while I'm doing the calculations, and I round down to at the end. Okay, 2 sig figs at the end. Okay, okay, so this is what we have. Okay, what do we want? They're asking for hydrogen peroxide. So this is our want. And our mole ratio, oh, it's an easy mole ratio, want over have, it's a 1-to-1 ratio. So that means I'm going to use up that many moles of hydrogen peroxide. But it's asking for mass. Okay, this is the substance that I want, but they want it in units of mass. So I'm going to convert. And it's going to be the mass of 1 mole of this stuff. So we have 2 oxygens and we have 2 hydrogens. So 34.02 grams on the top, 1 mole on the bottom. So the mass of 1 mole there. Moles will cancel. Going to multiply that by 0.0427, and I get 1.45 grams of H2O2. Okay, so I will have the rest of these filled out, and at some point I will post the answers. I would like you to check your answers to this worksheet and the other worksheets that I'll put up there, so that you'll be able to do the quizzes in the future with no problems. Okay? All right. Thanks.